Hi, and welcome everyone to the session about the Ceph storage solution. My name is Neil Hansen, and I'm a Senior Cloud Solutions Architect here at OpenNebula. For this session, we're going to have the presence of two great speakers. First, we'll have Ernesto Puerta from IBM, who will dive into the new features of Ceph Reef coming soon. And the second session will be led by Stefan Kuhlmann from BIT, who will talk about how they're using it as part of their private cloud deployments. Before they join us, I would like to make a brief overview of how Ceph is implemented architecture and just slightly how it works a little bit. We have a diagram here on the left that shows the inner workings of how Ceph is structured, with multiple hosts hosting the disks and multiple managers controlling all this information. This allows you to have a distributed storage system where the disks are replicated or striped across multiple hosts. It provides fault tolerance while still maintaining good performance. The Rados block devices are how virtual disks are stored and represented to virtual machines that allows things like snapshotting and other advanced virtual disk features. OpenNebula is capable of automatically deploying a Ceph backend storage system directly to your on-premises hypervisors or an edge provider like AWS using our hyperconverged infrastructure one provision system. The additional useful thing about Ceph is it's a software-defined storage, which reduces vendor lock-in, increases flexibility of the hardware you can buy, so you can keep costs low without being restricted to specific hardware vendors. And now is the turn to welcome our speakers. Remember, you can use this chat on the same page to send any questions or anything you have during the situation. So for now, I'll leave the floor to Ernesto Puerta.
Hello, my name is Ernesto Puerta. I'm a software engineer in the storage unit at IBM. I've been working 20 years in companies like Telefónica, Alcatel-Lucent, Bell Labs, Nokia, and Red Hat. And I recently joined IBM. I've been a Ceph user for 8 years. I was first for 3 years a Ceph user and then became a Ceph developer in the last 5 years. I've been the Ceph dashboard lead for 3 years and recently stepped down from that, and I'm currently involved in the Ceph MBMF over Fabrics project. So, well, this is probably too high level, but for those of you familiar with NAS and SANs, you might be wondering what's the main difference between NAS, SANs, and SDS, software-defined storage. So basically, it's about the scalability. So the scalability model in software-defined storage is the horizontal scalability or scale out, while NAS and SAN approaches usually lean more towards the scale up approach, basically relying on better and more performant hardware to increase capabilities. So many people coming from other distributed systems wonder what's the behavior of Ceph when there are issues in the network, how it deals with the different network conditions. So basically, those coming from the non-distributed world, like MariaDB or SQL, MySQL, all the classical systems basically are used to the CA thing. So basically, you expect that the system becomes consistent and also is fully available, but it doesn't support any kind of network partition. Sorry. In the case of Ceph, that's different. Ceph deals properly with consistency. In fact, it's called a strong consistent distributed system, and with partitioning too. But if there is, in that case, when the system becomes partitioned, it's not able to still be available, right? So it's trades off availability in favor of the consistency and partitioning. For example, if you are familiar with Cassandra, probably you are used to eventual consistency. So this is usually a thing that causes some headaches to people coming new to Ceph. So probably you have already seen this diagram. This is a slightly more complete diagram, but basically it explains the 3 main different access methods or protocols to consume data in Ceph: block, object, and file system. Basically, that's done through different components. So RBD, which stands for Rados block device, RGW or Rados gateway, which is basically the object gateway to Ceph, and the Ceph file system. And the underlying infra is basicly librados, which is a library that deals with the Rados protocol. that library is available to different languages. And in the core of that, we have different daemons that provide services like the monitors, managers, OSDs, and the metadata servers. So extending on that, the different access methods, we see that block device is probably the classic data approach. So we have that's suitable for VMs, for containers. In fact, there are, well, probably you're very much familiar with that. Containers, there is the Ceph CSI project, also for TVs, for transactional systems. And it is currently supporting iSCSI, and we are currently working to also support NVMe integration. So basically that will, for example, integrating Ceph with VMware systems. There is the object interface. So that's perfect for AML pipelines, for CDNs, asset media, cloud native applications, and also for archival and backups. And the last access method is the file system approach. So basically, as mentioned, if you're familiar with NAS systems, Ceph also provides NFS and CIFS, or well, CIFS support is not that yet there, but it's a work in progress. It basically provides a fully distributed system, so it is not just scalable, but it can be also shared, and it's also suitable for VMs. And we come to the release life cycle. So we were talking about RIF release. That's red line is basically where we are right now. So we are about to deprecate Pacific, which was launched 2 years ago. So the lifespan of the release is 24 months. We are in the middle of the Quincy release. So it's probably the most mature release right now. And then the RIF release is probably going to be launched in the next few days. So we have one other deprecated release, which is Octopus. Some users prefer to stay in all releases, but as I will mention now, the maintenance and the backporting policy doesn't cover those, right? So the Ceph project only covers the last 2 releases. So in this very case, Quincy and Pacific, and as soon as RIF is launched, Pacific will become end of life. Also for upgrades, you can upgrade as the releases are staggered. You can upgrade to the newest one and also to the -1. So basically, you can perform this, jump this intermediate release if you don't want to do that. So what about Ceph release, RIF release, which is the code name for the version 18th. So basically, in the different components, I will be speaking for each component. In Rados, which is the core component Ceph, we have more improvements on the QoS. Ceph uses mcloak as the algorithm for coordinating the quality of service. And basically, improvements are affecting the background IO. So basically, things like scrubbing, recover, backfilling, all these kind of operations will benefit from this. And it will match to coordinate with the client IO. So there is now a read balancer, which basically improves the distribution of data for reads. And there are also improvements in BlueStore, which has been a Ceph native file system. So basically, there are several efforts to improve that. Also, improvements in the way that the placement group log is managed, and also the storage cluster, which basically allows to deploy monitors in different data centers. Crimson and CStars are newer projects in Ceph. Basically, Crimson tries to replace the OSD daemon, which is the core of Ceph, basically where the data is stored, with a new rewrite based on CStar and a reactor approach. And that basically try to pin specific daemons or services to CPUs in order to provide high performance features. So we have also usability improvements there, the snapshot support, and attached to the Crimson project, there is CStore, which is a re-implementation or a new implementation of a object store, same as BlueStore is for the Crimson OSD. Right now, I mentioned that the RBD is the only workload support. There is for Squid, probably there will be RDW support for in Crimson. So RBD will have copy on writes clones, but with different encryption. Also improvements in the persistent writes back to cache, and also in the multi-site mirroring, these two areas are ones where the project is focusing more, and also the NVMe gateway, which is kind of an independent project, but it's basically exposing RBD images through the NVMe over Fabrics interface. In the Ceph FS project, we have improvements in FScript and Ceph FS Top, which is a command line tool to monitor the activity on the different file systems. Also in the snapshot diffs and the subtree rebalance. RGW is improving basically the S3 interfaces, keeping that in sync with the AWS S3 latest updates. So, for example, they are bringing the HTTP3 support and improving also the POSIX like RGW semantics, and also providing S3 select as well. Ceph ADM is the Ceph native orchestrator. So basically, if you are not using Rook, you will be probably using Ceph ADM. It's also providing OS tuning profiles. It's also dealing with these stagger upgrades that we previously mentioned. And it now provides RGW multi-site workflow, which was quite tough to configure. And things like key rotation, and it will be compiled in a single file, which will be easier to handle. And the Rook project is the other orchestrator, the one that deals with Kubernetes. So basically, it now brings support for the new Ceph exporter. It also deals with mirroring via Submariner. And the OSD encryption, rotation is also supported. And they are also bringing the SNS, the backend notifications in RGW. Dashboard team has recently revamped the landing page. And they also provide a new server-side encryption wizard. So basically, RGW can be easily configured when it comes to S3 and server-side encryption. RPD mirroring has also been reviewed and is now fully working. There is a couple of wizards. One is the one-click OSD creation, and also there's been an improvement on the Ceph auth X management. There is also centralized logging built on top of Grafana and Loki. And this has been part of a Gold Summer of Code project to bring WCAG AA level of accessibility. So that's been all from my end. Thank you.
Many thanks for that magnificent and detailed talk, Ernesto. Now it's time to see the deployment of Ceph in BIT, thanks to Stefan Koeman.
Hi, everyone. My name is Stefan Koeman, system engineer at BIT, in a small ISP in the Netherlands, business to business only. If you would like to reach out, you can get me at this email address. And we'll be happy to answer any questions you have. Okay, so all my slides are text only, so no fancy graphics here. I will give a short talk, and I hope that there's something in it for both users that are new to OpenNebula or looking into it, if they want to use it, and or are new to Ceph, and as well as for users that are already using it. So yeah, here we go. This one, yep. Yeah, so we love Ceph at BIT, and we also love OpenNebula, and it also turns out to be a great combination. I want to take a few seconds to mention that this year we will celebrate 10 years of production with OpenNebula, and 5 of those will we are running OpenNebula with Ceph as a storage backend. So it shows that we have a long history together already, and we're still happy users. So this slide is for people that are considering if Ceph can be an alternative to their current storage solution. We were there before, so like 5-6 years ago, and so wrote down a couple of reasons why we moved to Ceph, and why it made sense. So in our case, we had a big vendor that had nice boxes, but it still lacked performance. And the only way to improve the performance would be to replace this machine with a bigger box. and with also its own increased licensing costs. And yeah, it couldn't scale out. You could not just have multiple boxes and have them share the load. So like I said, it's expensive, and the price quality ratio we had was low. Support cost was high. We still had we still hit lots of bugs, although the product was already in the market for many years. And to get rid of them, we had to schedule a lot of maintenance windows to get rid of them. And in the end, we actually never got rid of them. We just bumped into new ones. So does that say that Ceph is bug-free? No. Does Ceph need maintenance? Yes, it does. But it does scale better in terms of performance and also financially. You can just buy what you need instead of what you think you might need in the future. So these were the reasons for us to move, and just also to take back control of the whole storage system in our cloud. Have more ways of deploying it the way we think makes sense. So how do we use Ceph at BIT? Well, of course, we use it for RBD, for our virtual machines. But as those block images can also be shared by means of iSCSI, we also use that mainly for VMware workloads, as well as MS SQL. We roll our own version of an iSCSI gateway because at the time that we needed this, the Ceph gateway didn't support SCSI reservations. It was a requirement for MS SQL. So we roll our own. We use LIO with RBD and NVD mappings and CTDB from the Samba project to make it high available. We use CephFS a lot. We use it to store a lot of mail, and shared web hosting platforms of ourselves and customers are stored on CephFS. And well, currently we're storing about 835 million directories and 441 million files in like almost 90 terabytes. So it's a lot of small files mainly. This comes with our own implementation issues. RTW, that's something we want to use in the future, mainly to use for S3. And we might replace our iSCSI solution with NVMe in the future. So we have multiple clouds running on Ceph. We have, of course, test and staging development environments. We use it ourselves and also for our customer clouds. And all those clouds, they get their own dedicated pool. That's something I will come back to later. As we are running a high available OpenNebula system in a cluster, we have high availability and also load balancers in front of our front end. And to make sure they have all the same consistent view of the file system it's shared, we use CephFS, and all images that are uploaded are available to all the nodes in the cluster. And the same goes for the Sunstone and FireEdge deployments to provide you with out-of-band access to the virtual machine results. So why would you want to use Ceph as an OpenNebula data store? So it's really easy to configure, and it is a great how-to on the documentation side of OpenNebula. And you just have to configure it once, and then you can basically forget about it. I've literally never touched it again. So that's great. If you need it, you can configure multiple Ceph clusters in OpenNebula. So that can be really useful if you want to have like one cloud and have different storage backends or separate clusters. For example, for testing or staging or whatever, you can use separate Ceph clusters within one OpenNebula deployment. We currently don't use it. We have like separate deployments for each, including OpenNebula, but it's certainly possible to configure it that way in OpenNebula, thanks to the flexibility of how Ceph is configured, but also how OpenNebula configures its data stores. Yeah, well, it brings a lot of awesome features for virtual disks, fit provisioning, snapshotting, cloning. You can have compression on the OSDs. You can have encryption in per image encryption, but also encryption on disk, like at rest. And you can have all your communication with the Ceph cluster in flight encrypted as well. So I had to think about one of the cons for why you should not use Ceph as the data store. I couldn't really think of any, but for some, it might be a deal breaker. You cannot currently take a virtual machine snapshot, like including the memory, as Ceph has a raw storage format, and to properly store it, you need and then a way to store the metadata, and that's in a raw disk currently not possible. Okay, so what lessons did we learn? Well, you start small and you can scale out. That's great. And then we first started with just using RBD. CephFS was shortly added to that list after that, and well, the use increased. And if you start using it intensively, like with millions or even billions of files or small objects, it will have an impact on the Ceph cluster performance. And that's due to some technical implementations, mainly RocksDB. Each Ceph release comes with new tunables and new ways of dealing with the influence of just running a lot of small objects on a data store. And to avoid effects from CephFS, for example, or RTW on your RBD cluster, you might consider to just run separate Ceph clusters for each protocol. You for certain know that they won't influence each other, and you can scale them individually or upgrade them individually if you need to. If you don't, then you can just leave it. So from an operational point of view, it makes sense to split them. And if you can't do that, then, well, I think the second best way to do it is to have dedicated pools for each service, and then use crush rules to have them pick the right pools. So yeah, and as I already mentioned, the read balancer in Ceph-Reef. So it's a really nice feature, I think, especially for smaller clusters. So if any of your users out there that are running small OpenNebula clusters, it makes a lot of difference, because you can better spread the reads that are done in a Ceph cluster, and it's not gonna move any data. It's just shifting or evenly distributing the primaries, the primary placement groups in a Ceph cluster, and that definitely does make a lot of difference. As they're also used, these primary PGs, to in recovery and expansion scenarios, and a lot of backfilling happens, and then even also that is better balanced across the cluster. So definitely something you would want to turn on as soon as you run Reef. So we'll shortly talk about some future improvements for OpenNebula. Ceph already supports RBD namespaces since Nautilus, and it would be awesome if OpenNebula would support them. and it would be great if Ceph would implement RBD namespace quota. And last but not least, have RBD namespace support and libvirt. So there's already support for RBD namespaces in QEMU and in Ceph, but it should definitely land in libvirt at some point in time. Patch is already there. This never got merged. And why does it? Why is it such a big deal? Well, like I said, if you want to run multiple clouds on the same Ceph cluster, then currently you would have to create pools for each cloud, and each pool takes up a certain amount of placement groups, and those have a cost in terms of CPU and memory. And with using namespaces, you would actually get rid of having separate pools. You could just use one pool and have each cloud use a namespace within that pool. So then you would not have to scale different pools or shrink them and move a lot of data around, which has its own cost in Ceph. But you could just use one big pool, use namespaces, and be done with it. So that would be really awesome. So then there are some other future improvements. Since Ceph specific, there's the possibility to have image live migration, and that's basically that you can start running a virtual machine with its disk still at a remote location. So, for example, HTTP server somewhere on another provider, and if you want to migrate to another to your Ceph cluster, you can basically start running the virtual machine. It will read all the data that is not yet merged or yet copied over to the Ceph cluster from the source, and it will copy it over in the background. So especially when you've got very large images and downtime is like an issue, this would be a really useful trick. And then there's something that Danny Harnick presented as a proof of concept at Ceph in the CephLaCon, and as I mentioned in Amsterdam, and that's the incremental backup and instant restore feature. So this feature would give Ceph the ability to incrementally backup RBDs, store them at a remote location, and over time just store the incrementals. And then if you want to restore, like for example, for disaster recovery, you can instantly start the virtual machine, the same like the disk live migration feature, and then slowly copy the data over from the external source, which can be HTTP file or S3 bucket. So this would be really useful for disaster recovery scenarios. Yeah, that was. There's many more things to talk about, but we have to keep it a bit short today. That was all that I had to say. Here's a link, and there's some more links over here. So I want to thank OpenNebula for having me, and if you have any questions, just ask in the chat. Thanks.
Okay, thanks a lot for your use case, Stefan, and thanks for participating in our virtual conference. This year, our lineup is definitely full of real examples of different ways to use OpenNebula. I just would like to remind everyone in the chat that you can ask your questions in the chat you'll find on this page. I hope you enjoyed this session and continue watching us. Stay tuned for the next session coming up soon.